I adjusted the vertical height and linearity so it's a bit more in line with what it should be. It shouldn't fill up the screen entirely. But clearly it shifted way too far over to the left. So what do we do about that? Well, that is what these 4 screw adjustments are for on the back. They can tweak this focus coil to center the picture. Which is a bit of a pain to do, but we'll see what we can get to quickly here. It's hard to know which screw to adjust and whether to tighten or loosen it. Later sets, they had a gimbal. They could adjust this up and down and left and right. Made this process a whole lot easier. So it's not usually at all obvious which one you adjust to make it go the way you want. Are not having much of an effect. It's moving a little bit, so I suspect I'm going to have to play around with these a bit. As this set uses, well, I've got the mask right up here. It's what they call a double D, which means it looks like 2 Ds back to back. It's a way to maximize the screen. Earlier sets used a rounded rectangle, because really it's a 4:3 format rectangle. But one way, the kind of an advertising gimmick to maximize the screen area was to use a double D. So you lose the corners, but you could use the full width, and then you chop off the height. So this image has got to move over to the right. Although it might not be a centering issue, then it just occurred to me it might be a horizontal linearity issue. And the centering might be fine, but the image is compressed on the right and maybe stretched a little bit on the left. So what I really need to do is get a crosshatch pattern on here, because I might be adjusting the wrong thing.
In time, those hands came alive. Can you believe it? Supple, soft, flexible, and alive.
And as far as retrace lens goes, an easy modification to reduce those. I mean, you can always get rid of them by tweaking the controls, but often, especially when the picture was a little bit weaker, you've got to make it quite dim to get rid of those retrace lines.
It was those wonderfully incredible hands that once were his, and now they're mine. They still fought you? Yes, they fought me. The spirit came back into them even as the life had done, and they fought me. They tried to tear me to pieces when I was sleeping, to wreak their vengeance on me, to kill me. They became alive with a savage, monstrous will of their own. Then you came, Mr. Welsh, full of slides.
Well, here's a test pattern, and actually the linearity looks pretty good, so it really is an issue, I think, of adjusting those screws on the back to shift this picture over to the right. Well, I tried adjusting the drive and the width control. This is about as good as I can get it. Linearity is off a bit on the left, and the width is not as wide as it should be, and this is with the controls kind of maxed out. So I think I got some work to do on the horizontal circuitry, including something I want to do right now with the help of that RCA scope I picked up recently, and that is adjust the horizontal synchro guide to make sure it looks like that. And this is the actual manual for the scope, and they have some tips on checking out the horizontal circuitry. And they even show you where to clip it up on here. They use the yellow lead, so that's what I will do. They also have the original Admiral service info with that same waveform here, and they tell you exactly where to hook it up. TP17, which you can see on here, it's terminal C on that coil, so that is what I'm going to do. There are little letters on the back of the coil, and C is in the upper left, so that's where I've got my scope hooked up. And here's the waveform. The RCA manual indicates when you're working on horizontal circuitry to put the sweep in this position between 1500 and 15 kilocycles, which makes sense because we're working with a signal. It's about 15 kilocycles. And you can see this waveform's a bit off the top of the scope, so I'll adjust this switch. Oh no, that's the wrong way. And one more. There we go. And then I'll adjust this to get a better lock. And there we go. And as we can see, things are way off. Waveform shape is kind of okay, but this peak here should be the same as that. Now remember, I had to adjust that coil a lot when I first turned it on. I was adjusting the oscillator, the free running frequency, and that's accessible on the back. There's another slug on the inside, and that alters the shape of that waveform. This is something you really can't do without a scope. So I'll get this alignment tool on that shaft there. Let's see, a little turning on that is a noticeable effect on the wave shape. Get those to be equal peaks there, and adjust the vertical position so I can get it right on that reference line to focus a little better. Could also knock down the voltage range. You see, even though the waveform's going off the bottom of the screen, don't really care because I just care about that top part. And a little bit of a tweak. Get things perfect. Alright, cool. So you see, I don't care about the actual exact peak voltage or the frequency. I just want looking for that shape. Now, that didn't really help my width problem much, but I didn't expect it to. For that, I want to take a look at some other signals, especially this input to horizontal output, pin 5. Now that I do care about the voltage, 30 volts peak to peak. So for that, I need to refer to this manual and see how to use this VCal to get this calibrated so that I actually can read the voltage off of this vertical scale. Okay, I've got the yellow lead attached to the grid of the horizontal output tube now, and I want to know what that voltage is peak to peak. Well, I can certainly adjust the vertical attenuator knob and make it shorter and taller. And there are a couple numeric scales here, but after consulting the manual, I know that I need to calibrate it first. And they have a built-in reference for doing that. You take this knob, go to the calibrate position, drop this down to the 15 to 150 range, get it synced, and adjust the vertical cal so that it just goes from the 0 line to this horizontal line. And tweak the position too if you have to. So, right about like that. Looks pretty good. And now if I go back here, it is calibrated. I'm going to change the time base back. So I am on the 6 scale. A little hard to see. Red lights, maybe that'll help. That's a little better. So there's 2 scales here. One goes 0 to 2, one goes 0 to 6. Well, that corresponds to these ranges. So if it has a 2, 0.2, 220, use the 2 scale. If it has a 6, use a 6 scale. And I've also, remember with the yellow probe, it's got to divide by 10 attenuator. So you got to multiply this by 10. So that's actually, when it says 6 down here, it's actually 60 up here. So 0 to 60. So I have got approximately 40 volts peak to peak. And service manual. Refresh my memory here. This shows it as about 30 volts peak to peak. And the shape looks very similar. So it's a little high, and even so, I don't have sufficient width. So what I want to do next is check the DC voltages on that horizontal output tube, which is a little tough to get it down here in the corner. So referring back to the schematic, I especially want to know what the screen voltage is, which is this guy here off that 100 ohm resistor, and the cathode voltage, the 82 ohm resistor. So if I know what this cathode voltage is, I know how much current is going through the tube, because I know this is an 82 ohm resistor. And screen voltage has a pretty big effect on how this thing is biased. And then I'm measuring right here, I'm measuring the drive, so I'm going to go into this 47 ohm resistor. Because I've tried a couple horizontal output tubes, and they both have a bit of a blue glow, which makes me think it's being overdriven a bit. Yet I don't have sufficient width, so something doesn't seem quite right, and I'm hoping it's just that the tube bias is off. The voltages on the horizontal output tube looked really good, so let's see if I can do get the width, full width, just by adjusting the controls on the back. So they say to adjust the horizontal drive control, so it's as far right as you can go. Right now I got it cranked as far right as it can go, and then back off until you get the best linearity. Which seems to be about here. If I go any further left, it's getting really stretched out on the left. So let's bring that in. So you see it's not filling the screen completely, but there is a width coil on the back. It doesn't have a huge effect. I'm hoping I can increase it enough such that it fills the screen. And to do that, I'm going to switch to some actual programming while I adjust it. Actually, it's programming rather than commercials. Alright, so see where the edges are now. So I'm going to take my tool here. It's a usual slug on the back with a brass shaft and a slotted end. Put that on there. Start cranking down on it. Oh yeah, it is getting wider. Excellent. Question is, well, I won't have enough adjustment range. Yeah, alright. Yeah, that is filling up the screen. Excellent. Oh, not quite. Not quite. I'm not on the right edge. I might need to tweak the centering a little bit to get it over to the left more. Alright, that looks pretty good. I'll look up that mod to get to suppress these retrace lines. Things are looking pretty good. So my biggest concern when I first powered this up was that the tuner would be all messed up. But the tuner actually seems to be fine. Excellent sound too. So I'm not going to mess with an alignment. I just don't see any reason to.
I didn't mean to be harsh. But you weren't. So you want to shoot me now? You go ahead.
Since the set has been working fine, I went ahead and reattached the cans. All I did was just a corkscrew to pull out the inside. Didn't even need any heat. And then just use a little bit of epoxy around the perimeter, glue them back down. They're plenty strong, but if I needed to, I imagine a good whack would break the can back off and I could get at the insides. Alright, now I want to add retrace suppression. Now it's going to vary for every make and model of TV, but the basic idea is you want to find a vertical pulse somewhere on the side of the right polarity and apply it either to the cathode or the grid, depending on how this set is designed. This set feeds the video into the cathode, so the grid is where you want to do your retrace suppression. So in the original schematic, the grid is just going to the brightness control and that's it. So what you do is you break that connection going to the brightness control and add a resistor in series 270K. And from that new junction there, add a capacitor going over to the vertical circuitry, in particular the vertical oscillator tube. So there's a junction right here of this capacitor and this resistor. That's where you can get your signal. But you also need to increase this resistor from 3.9K to 8.2K. I'm just glad somebody else figured all this out and I don't have to go through it. I got this from Ryder's TV Servicing Tips and Tricks. Here's a look underneath the chassis. This is the brightness control. And it's the front potentiometer, and here is the wires just going all the way straight through to the CRT socket. So we need to attach some components. So where can we put them? Well, there's a little terminal strip here that's full up, but I suppose I could extend that by attaching another one to it, or replacing it entirely with one that maybe has 5. And we've got one spare lug down here. So I'm going to try, I think, to just make use of that lug down here. So if I get 270K and attach a long extension to it, I can run it from there to there, reroute this wire over to here, and then from here I need to run a capacitor over to this junction. So let's see, where might that tube be? I believe this is the 12AU7 down here, I think. Be the blocking oscillator transformer. That must be the 3.9K right here going to ground. Yeah, and there's that cap. So from this junction, okay, yeah, that'll work out. So I need to run a cap from here to here. A bit of a long run, but with an axial cap with long leads on it, it'll make it. So capacitor from here to here, and a resistor from here over to here, and move this wire over there. Okay, replace the 3.9 with an 8.2, attached a capacitor to this unused tie point, added the 270K resistor with an extension wire over to the brightness control and rerouted the grid, pin 2 of the CRT over to that tie point. Now let's see if that actually did the trick. Now I'm not surprised that the vertical's messed up. They even mentioned the service tips of that after changing that 3.9 to an 8.2K resistor, you're going to need to adjust the height and linearity and hold. And yeah, I can see the linearity is messed up too, but important thing is brightness all the way up, no retrace lines. Cool.
Listen to me. I told Marshall, and I'm telling you. Now swear to me that you will do it that way.
Mind if I think it over?
Now notice the width isn't quite all the way over. Well, I've noticed that the set needs to warm up for a few minutes, then the width will completely fill out. So before I get the test pattern up and do one final check of the linearity, I'll let it run for a while. So that's about it. But I do want to show you guys a little bit more with that oscilloscope. Even though I don't really think this set needs an alignment, I at least want to see if I can hook it up so I can see the current IF response curve. One thing I'm not sure about is, will it work with this WaveTech 1002, which is what I usually use for my sweep generator. We shall see. Well, this actually works better than I expected. Just keep in mind that the response curve is inverted from what they show in the service info. Some more modern scopes have a switch to invert the vertical input, whereas this does not. So this is actually zero baseline, and just think of this as being the signal coming through, which would normally be up. Well, we're just going to see it upside down. So what have I got set up? Well, as indicated in the service info, Got the set tuned to an unused channel, got the contrast turned all the way up. Output of the sweep generator is going to the shield over the 6J6, which is lifted slightly up so it is not grounded, and I got terminating resistor on the end of my cable, 75 ohms, which is the output impedance of the sweep generator, which is set to about a center frequency of 22 megahertz, with the sweep width of about 10 megahertz. This uses a 21 megahertz IF. So your frequency response should go from around 21 to 25, 26 megahertz, let's say. Alright, so that will give you a nice curve. Now what about markers? Well, normally I would take the output of the set O, which is connected, again, as indicated. You hook up a 10K resistor and a 330 picofarad cap. At a certain point, you hook up the scope there. This forms a decoupling filtering circuit. But that's so specific to every TV, just ignore that unless you're working on this specific Admiral chassis. Anyway, so wherever your service info indicates to hook up the scope, that's where you hook up the scope with the yellow high impedance lead. And this is set to a line sweep. And this is set to line sweep. That's why they're synchronized. Normally, I would use a scope like this in XY mode and take the X and Y outputs from the back of this device and directly drive the scope with that. But in this case, vertical out of the TV and the horizontal and sweep generator are both synchronized to the AC line. So, if I used the DMOD input on here going to the set, and then you hook up the outputs of that to an XY scope, I could use the built-in markers. However, if I'm just going to use the output on this, you don't get those nice built-in markers. So, how can you get a marker? Well, if you got a nice accurate RF generator, you can take the output of that and combine it. I'm just using a 30 picofarad mica cap here to combine the outputs of these two generators together. So this is going to form a marker. Right now it's at 22 megahertz, so you may notice there's a little squiggle here. That is 22 megahertz. Increase that a little bit. I don't know. Oops. Frequency 22.5 megahertz. And notice it's down here a little bit. I'll try going to 23. Okay, there we go. So bam, we know we've got a peak at 23 megahertz. Where do they say these two peaks should be? Well, they don't tell you exactly. But the width should have, let's see, if we could put one marker at 25.75, then we should have a width of about 3.2, so the other marker would be at 22.55, I guess. So let's try 25.75. 25.75 megahertz. And it's right over there. So I figured the alignment on this set must be pretty darn good, because I'm getting a really sharp picture, so much so I can actually see chroma dots leaking through. So that's why I don't want to mess with this. I just wanted to show you guys that you can indeed use this simple, inexpensive, super basic scope to do an alignment. You're just really going to need some way to do markers, because without these markers you're really lost. You just don't know where these peaks are without having some kind of squiggle on there to tell you where you're at.